All right, so the last, we're going to just cover a few things. I'm going to talk about type 1 and type 2 errors. All right, when you do a hypothesis test, so type 1 and type 2 errors come with hypothesis tests, okay? So at the end of a hypothesis test, you make a decision, okay? And that decision is either going to be what? Okay, reject what? Reject the null hypothesis, or don't reject, okay? Don't say accept. I know in day-to-day life, if you don't reject something, you're accepting it. But in statistics, when we say we don't reject, we mean we don't reject, okay? So these are the two decisions we can make. We either reject the null hypothesis or we don't reject the null hypothesis, okay? Now, the truth is these might be the decision we make, but in reality, okay, so these are our decisions, but in reality, there are two possibilities, okay? The reality is that the null hypothesis is true, or the null hypothesis is not true or is false. Okay? So ideally, what are our decisions? Ideally, if the null hypothesis is true, what is the decision we want to make? Do we want to reject the null or not reject it? Yeah, if the null hypothesis is true, we hope the decision we make is not reject the null. Okay? And ideally, if the null hypothesis is false, we hope our decision is to reject the null. Okay, I heard you guys say that. So those are the ideal situations. Okay? If the null hypothesis is false, we hope our decision is to reject the null. And if it's true, we hope we don't reject the null. That makes sense, right? Well, sometimes, in no fault of our own, okay, so we could do the math, we can do all of the steps correctly, but because of the nature of random sampling, we might make the wrong decision, okay? So here's an example. Maybe the true proportion of males and females is 50-50, okay? But you take a random sample of people, and in your random sample, just for whatever reason, you happen to get a random sample with 60% women. Okay, it's possible, right? You need two random sampling, you could get an unusual sample. And if you do the math based on that unusual sample, it might lead you to the conclusion to reject the null that the proportion is 50-50. Okay, that the proportion of women is 50%. Okay, your sample might lead you to believe that the proportion of women is more than 50%. Okay, so in that case, you didn't do anything wrong in terms of your math and the steps and the calculations, but just because of the unusual sample, you were led to make the wrong decision. Okay, does that concept make sense? That you might be led to the wrong decision just because the random data you observed happens to be weird. And again, when you're doing this hypothesis testing, you're assuming your data is representative of the population. So because of random sampling, you could get a sample that's not representative that leads you to the wrong conclusion. Okay? And so when you make a mistake like that, we call those errors. And it's either going to be a type 1 or a type 2 error. So I'm going to write sometimes from random sampling, we get an unusual sample that leads us to the wrong conclusion. Even if we do all the steps correctly. Okay. And the tough part is that we don't know whether we've made the right or wrong decision. There's no way to know. Because anytime you take a sample, you're just hoping it's representative. But sometimes it's not. So let me save that. This is Stats 10, March 10th. Slide 1. Okay. So there are two mistakes we can make. So let me just, and we got really creative in naming them. Type 1. Type 1 error is, in reality, the null hypothesis is true, but we make the conclusion to reject it, or we make the decision to reject the null hypothesis. Okay. How often do we make a type 1 error? Okay. Sorry, I don't know what's going on over here. How often will we make a type 1 error? Okay, the probability of a type 1 error is equal to alpha. Our choice of alpha is directly related to how often we make a type 1 error. Okay, so if alpha is 0.05, we will make type 1 error 5% of the time. Okay? And we get to choose our alpha. We get to choose alpha to be large or small. In general, we choose 5%. That seems to be the general consensus. But you might say, well, if alpha is directly related to type 1 error, why don't I just pick a tiny alpha? Okay. Well, picking a tiny alpha has the reverse effect, or the negative effect, of increasing our type 2 error. Okay. So a type 2 error, okay, this is, in reality, the null hypothesis is false, but our decision is not to reject the null hypothesis. Okay? So again, ideally, when the null hypothesis is false, we reject it, but a type 2 error is the null hypothesis is false, but our decision is not to reject the null. Okay? That's a type 2 error. Okay? Decreasing alpha increases the probability of a type 2 error. Okay? And we assign the letter beta. Type 2 error, the probability of a type 2 error is equal to beta. Okay? So type 1, the first letter of the alphabet is A, so it's alpha. Second letter of the alphabet is beta. Okay? And that's actually where we get the word alphabet, alpha, beta, alphabet. Okay, if you guys care about this stuff. What? So it's literally saying the ABCs, but we're just saying AB, alpha, beta, alphabet. So type 2 error is beta. Okay, and then we have something called power. Okay, power is equal to 1 minus beta. Okay, whenever we do 1 minus something, what does that mean when we're talking about probabilities? It's the complement, right? Okay, 1 minus something is the probability of the complement. Okay, so power is talking about the probability of the complement to a type 2 error. So what is the complement to a type 2 error? No. What is a complement? Okay. So if I say we've got event B, what's the complement of event B? Not B. Okay, don't say A. So either B happens or not B, okay? Or B doesn't happen, okay? So either we make a type 2 error or we don't make a type 2 error. What does it mean not to make a type 2 error? So power is the probability of not making a type 2 error. Okay. And what does it mean to not make a type 2 error?
1 minus beta.
No, that's the probability, and that's power. But I'm asking, what does it mean? Okay, type 2 error is what? It says, in reality, the null is false, and our decision is not to reject the null. So not making that mistake would be to not make the mistake. So that means in reality, the null is false, and our decision is to reject the null. And that's a good thing, right? So that means in reality, null is false, and we decide to reject the null. Okay? So the type 2 error is making the mistake of not rejecting it, and power is the probability that you correctly reject the null when the null is false. So that's power. Yeah, we won't get, so there are values that can be calculated and all of that, but we're not going to get into that. Okay, I just want you to be familiar with these concepts. If you're interested in calculating the values of beta, we can talk, and I'll be happy to explain all of this, but it's beyond the scope of our course. But you do need to be familiar with type 1 error and type 2 error, and understand that even if you do all of your steps correctly, your decision might be mistaken just because, well, you're only dealing with limited data, right? Is power only referred to as, yeah, power is 1 minus beta.
So it's never 1 minus alpha?
No, 1 minus alpha is what we call the specificity of the test, and that's something else. Not to worry about. Okay. So, just like you're at the supermarket and you're going to buy a watermelon, and I don't know there's different ways to do it, right? And some people say you tap it and you hear for an echo or whatever.
The best vibration is the best watermelon.
Yeah, so yeah, there's different ways to do this, and the truth is you don't know if it's going to be good or bad until you cut it open, right? And you can do all of these tests, but until you actually eat it, you don't know if you got a good one or not. And so, in the same way, you can have data, and you're just hoping that the data you're getting is good, but you don't know if that decision was right or wrong, okay? Unless you got observe the entire population, which we actually never get to do. Okay, so that is type 1 and type 2 error, and I want to cover sampling methods. And this is the last bit of new stuff. Okay, so sampling methods are ways for us to get samples from the population. Okay, now you've already learned about one sampling method, and what sampling method is that? Simple random sampling, okay? So one method is simple random sampling. Okay, and I'm going to list off the 3 other methods that we're going to learn. And that is stratified sampling, cluster sampling, and oh my gosh, my brain is drawing a blank here. Stratified sampling, cluster sampling, and systematic sampling. Okay. Now, when we do our hypothesis tests and our confidence intervals, we assume we've done simple random sampling. Okay. But sometimes simple random sampling is difficult to do, so we might have to employ one of these other methods, which help us get representative samples, but it might not always happen. Okay, so I'm going to just I'm going to list off, define each of these one by one. Okay, so the first one that we're all right. The first one we learn is simple random sampling. Maybe 15 more minutes, and we'll call it a night. All right? How's that? I hope no one is too heartbroken about that. Simple random sampling. Okay, we might call this SRS. The idea is we have a list of everyone in the population. Okay, the list is called a sampling frame. Okay, and we select people one by one at random from the sampling frame or from this list. And that's simple random sampling. Okay. The difficult part is getting the list of everyone. Okay. Because if I said, give me a list of every single person who lives in Los Angeles County, you couldn't do it. Even if I say, give me a list of everyone who lives on your street block, it's going to be kind of tough, okay? Getting a list of everyone is difficult. So that's simple random sampling. You know, I've been posting these notes online. I don't know if you guys knew that. Is that there on the? Well, I'll show you. It's easier to take pictures this way than going to the website. So just to let you know, I will show you. Small detour. Under lecture videos, as long as I've been doing these this style. I say notes right here. And I'll do the same for today. It shows up. Well, if this thing loads. Okay, anyway. So we'll go to the next topic. Ta-da! So these are the notes from last week. So there, okay. All right, so that was simple random sampling. Let me talk about stratified sampling. Stratified sampling, and we're going to talk about cluster sampling, and they sound similar, but they're very different. Okay. In stratified sampling, the population is divided in subgroups okay, and we are aware of the proportions of these subgroups. Okay, so, and then we randomly select our sample so that the proportions in our sample match the proportions in the population. So the proportions of subgroups in our sample match the proportions in the population. Okay, so for example, okay, maybe the high school has 35% ninth grade, 30% 10th grade, 25%, let's do 20% 11th grade, and 15% 12th grade. Okay. Kids dropping out of school. Sad truth. Okay, so maybe the school has these proportions in the population, okay? When we take a random sample, we make sure the proportions of our sample match the population. Okay, so our samples should be 35% ninth grade, 30% 10th grade, 20% 11th grade, and 15% 12th grade, or something like that. Okay, so that's stratified sampling. And on the other hand, we have cluster sampling. Okay, in cluster sampling, the population also has subgroups. Okay, but we're not concerned about the proportions of these subgroups. Okay, the population also has subgroups, and in this case, it is hard to get a list of everyone in the population. But it is easy to get a list of all subgroups. So we take the list of subgroups or clusters, and randomly select some clusters. Okay? Then we do sampling within the selected clusters. So let me go to the next slide here and do an example of cluster sampling. Oh, you go back? Sure. Oh, shoot. Where did it go? Where did it go? Okay. So here's an example of cluster sampling. Okay. So let's say you want to take a sample of people who go to church. Okay. Now, to do simple random sampling, we would need a list of every single person who goes to church. And that would be pretty tough to come up with. Okay, it would be hard. Okay. It would be difficult to get the list of everyone who attends church. Okay? But it is relatively easy to get a list of all churches. Okay? So in this case, the churches are clusters. Okay? So it's relatively easy to get a list of all the churches. And then so we take the list of all the churches, and then we randomly select churches. Okay? So we randomly select some of the churches. Some of the churches on this list. And then we do random sampling within the selected churches. Or we survey everyone in the selected churches. Either or, okay? Okay. What's that? Or you survey everyone. You either do random sampling within the church or you survey everyone. Do sampling or survey everyone. Okay? But the key here is that it's difficult to get a list of everyone, easy to get a list of clusters, so you randomly select clusters and then sample within the clusters. So that's cluster sampling. Okay, and the last one, systematic sampling. So systematic sampling works best when there's a line or a queue. Queue is also a weird word, right? It's just like the letters kept going. Here's the Q, and here's a U and an E and another U and another E. Q. Okay. Works best when... Oh my gosh. Killing me. Microphone. All right. So this works best when there's a line or a queue. Systematic sampling. Okay. And basically, you just survey every nth person. So, like, survey every 8th person in line. Okay. Yes?
What is that? Every n?
Nth, where n is just some number.
Okay.
Whether it's the 8th person or the 10th person or the 3rd person, whatever you want. Just you don't want to get everybody because that might be too much work. So you just say, okay, every 10th person who goes through the line gets pulled aside for random screening or something. That's not how it works at the airport, but they could do it that way. Okay. They might, maybe for checking luggage, they might do that, but not with people. They're a little bit more, not random. So, okay, and that's systematic sampling. So on the final exam, you'll have 4 questions related to these sampling questions, and I'll describe the situation, and you say, this is cluster sampling, or this is systematic sampling, or this is random sampling, or stratified sampling, okay? And so it should be easy. Here, I'll just give you an audible example here, and you think of the answer, don't shout it out, and we'll go with that. So, oh, and there's examples in the practice midterm, so, or practice final. Okay, so here's an audible example. So I might say, an elementary school has a bunch of students. They've got 30 different classrooms. So they randomly select 5 of the classrooms and survey all of the students in each of the selected classrooms. This is an example of simple random, stratified, cluster, or systematic. Okay, so let me say it again. Don't shout out your answer. Elementary school has a whole bunch of students. They've got 30 different classrooms. They randomly select 5 classrooms and survey all of the students in these selected classrooms. What is this? This is cluster sampling. Okay. All right, so this week, your homework. You just have a few homework problems from the book. Your main part of the homework, and nothing's going to be collected. The main part of the homework is to work through the practice final exam. Next week will be our review, and I'm going to work through the entire practice final, okay? So your assignment is to work through that. I promise you the review session will be much more beneficial to you if you worked through the practice final problems, okay? Rather than just showing up here having not done any work. So work through the practice final, and then we'll go through the review. You can ask questions, whatever, and we'll try to get you ready for the final exam. Okay, we'll see you guys next week.